the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on videos.
Guys, welcome to Smart Guide video tutorial on the course Telecommunication Engineering 1. So I will be the one taking you in this course, Telecommunication Engineering. So I will make sure I simplify it to the simplest level that you are going to understand this. No need to panic. I wish you good luck. So before we start, I recommend you downloading a tutorial summary created by Fourier. So you can find the link on in this page. You can check. You see it's a summary that she created last year on Fourier series, because we are going to be talking about Fourier series and Fourier transform. So starting with this question, we are having a question here. It says the following are Fourier series expansion, which means these are the equation they are talking about. So if f of t is a non-periodic signal, so take note of this statement, a non-periodic signal. So we are asked to derive an equation that can be used to analyze it. So we are also asked to name the derived equation. So after deriving our equation, we are asked to name it. So we are asked to name the equation. So let's dive in. Solution. So let's call this equation the f of t equation 1, and let's call this equation 2 lambda n. So in some questions it can be given as lambda n, sometimes it can be given as an. Whatever it is, just take note of the equation having 1 over t integral of half of t to minus half of t f of t exponential minus j omega t dt. Just take note, it can be represented as anything. So we know that from our physics, we know that omega is equal to 2 pi f, and we also know that frequency is equal to 1 over time. So now let's represent this as a change in f, a little change in f. So if we are representing this as a little change in f, we are having omega is equal to 2 pi, it will be change in f. So change in f is equal to 1 over t. This is going to come in handy, so let's take note of this little expression. So now simplifying equation 1, f of t as change in f. So anywhere we see omega, we are going to represent it as 2 pi change in f, and anywhere we see t, we are going to represent it as 1 over change in f. So now we are having f of t is equal to summation n is equal to infinity, open brackets, lambda n exponential j. So I said anywhere we see omega, we can put 2 pi f there. So we are going to put 2 pi change in f. So we are having n t. So this is what we are having. So let's call this equation 3. So now simplifying equation 2. So in order for us to simplify equation 2, we are going to have lambda n is equal to 1 over t. So I said we are going to represent t in terms of change in f. So we said 1 over t is change in f here. So we can simply write change in f integral of t over 2 minus t over 2 f of t exponential minus j. Instead of putting omega, we are going to put 2 pi f n t. So this is what we are having after simplifying. This is equation 4. So now we were told in the question that this is a what? This is a non-periodic signal. A non-periodic signal. So it's a non-periodic waveform. So for a non-periodic signal, that means it tends to infinity. So you can have a signal like this. It tends to infinity. It doesn't stop. It keeps going. So we have t tends to infinity. So for when t tends to infinity, it's going to affect our equation, because you know we are having t here. So now when t tends to infinity, it's definitely going to affect our equation. So when t tends to infinity, these are things that it's going to affect. So summation will become integral. When t tends to infinity, summation will become integral. Our change in f will become df. So instead of changing f, we are going to have df, and n change in f will become ordinary f. So this is what is going to happen to our equation when t tends to infinity. So now let's substitute this into our equation. So substituting this into our equation, we are having f of t is equal to summation. So instead of putting summation here, we are going to put integral, right? Since we said summation tends to integral, so we are having integral. So it's going to be infinity to minus infinity, open bracket, lambda n exponential j 2 pi. So here we are having change in f and n. So we said change in f, change in f is going to be t. So we are having t. Change in n f is f. So we are going to have tf, right? Or ft is still the same. Let's call this equation 5. So changing equation 4 also, we are having lambda n is equal to, so instead of putting change in f, we say change in f tends to the f. We are having the f here, the f integral of, so since t tends to infinity, we can put infinity over 2 minus infinity over 2 f of t exponential minus j 2 pi. So we are also having change in f here, right? Change in f here, sorry. Change in f. So instead of putting change in fn, we are going to have ft, right? So let's call this equation 6. So this is what we are having after t tends to infinity. This is what we're actually having here. So now, looking at this equation very well, they are related because here we are having lambda n. Here we're also having lambda n. So we can substitute lambda n into equation 5. So substituting lambda n in equation 5, we are going to be left with f of t. Now we are going to have f of t to be equal to integral infinity to minus infinity, open bracket. So now instead of putting lambda n, we are going to put lambda this entire expression since we are having it. So here will be the f integral infinity divided by 2 is infinity, because infinity is a very big number, it's still infinity, minus infinity f of t exponential minus j 2 pi ft. So this is our lambda n. Then the last expression we are having there, which is this expression now, exponential j 2 pi ft. So this is what we are having here, but don't forget, you see I forgot to insert dt here. Here we are having lambda n comes with dt. So sorry, here we are having dt. Don't forget, you know, in mathematics, if you make a little mistake, that's the end of it. So take note, lambda n we are having dt. As you can see here from the question, we are having dt. So here we are having dt. Let's insert dt in all the part of the equation. Here we are having dt. So now here we are also having everything dt. So now, further simplifying our equation, let's arrange it very well. We are going to have f of t is equal to integral infinity to minus infinity. So for us to arrange this properly, let's open the brackets. We are having the f integral of infinity to minus infinity f of t exponential minus j 2 pi ft exponential j 2 pi ft dt. So now, looking at this very well, we said previously that omega is equal to 2 pi f. So we can simply substitute anywhere we see 2 pi f, we can simply substitute omega there. So now we can also say d omega over the f. If you differentiate this equation, we are going to be left with 2 pi, right? Because any differentiation, so we are going to be left with 2 pi. So we can say the f is equal to, simply with times, we bring this here and we bring this here, we are going to have the omega over 2 pi, right? So now take note of this. We are going to substitute it in our equation. So now we are having f of t f of t is equal to integral infinity to minus infinity. So instead of putting the f here, we are going to put the omega over 2 pi integral of infinity to minus infinity f of t exponential minus, so instead of imputing 2 pi f, we can simply put our omega there, j omega t, and lastly we are having exponential j. Instead of putting 2 pi f, we are going to put our omega there, t dt. So this is what we are having. So now for us to simplify the equation, let's represent this expression as a function called f of omega. So let this become what? F of omega. Let's call this f of omega. So we are kindly saying f of omega is equal to integral infinity to minus infinity, right? F of t exponential minus j omega t dt. Let's bring this dt inside, so the t will be here. Let's forget about this. The t is also part of f of omega, so dt, right? So now this is f of omega. So now f of t can be further simplified into, if this is f of omega, can be further simplified into f of t is integral of infinity to minus infinity d omega over 2 pi. So instead of putting this entire expression, we are going to put f of omega. Then now we are having exponential j omega t dt. This can be arranged as, this can be further simplified into f of t is equal to, let's factor out 1 over 2 pi, since we are not, it is just a constant, 1 over 2 pi integral of infinity to minus infinity f of omega exponential j omega t. Sorry, we are not having the t here, since we said the t is going to be inside this equation, so I forgot to factor it out. So the t, we brought the t inside here as part of f of omega, so this is what we are having in our expression. So now don't forget, we are also having the omega, since we are rearranging the omega. So now f of t, we know that our f of t now is this expression. F of t is this expression, and f of omega is this expression. So now let's write this now for us to see what we've derived. So for us to see what we've derived, we have f of omega. We said f of omega is equal to integral of infinity to minus infinity f of t exponential minus j omega t dt, and we said f of t is equal to 1 over 2 pi integral of infinity to minus infinity f of omega exponential j omega t dt d omega. So now this can be called, this is Fourier transform. This is called Fourier transform. So this equation is called our Fourier series. Fourier series. So this is called Fourier transform, and the other is called Fourier series. Generally, the two equations are called the Fourier pairs. So the two equations are called Fourier pairs. So because they are just like a twin, we are having f of omega is equal to integral from infinity to minus infinity f of t exponential j omega dt, and the other one you can see it here, 1 over 2 pi integral from infinity to minus infinity f of omega exponential j omega d omega. So we've come to the end of this tutorial. So you can see we are asked to derive an expression that we can use to analyze it. So these are the two equations that can be used to analyze any function. Any function you are given, you can use Fourier transform or Fourier series. So you can move from frequency domain to time domain with this equation. We also name them We also name them as the Fourier transform and Fourier series. So I hope you enjoyed this tutorial, and I hope you understand what I've just explained here. If you're having any confusion or you have any recommendation, you can put it on the comment section. We'll meet in our next tutorial where we'll be solving lot of questions on Fourier transform, because in telecommunication we'll be dealing with Fourier transform, not Fourier series. Thank you.